Hi, everybody. Welcome to Physics 121 Mechanics. This is the summer intensive session for Case Western Reserve University for the calculus-based introductory mechanics course. This summer course is usually taught in person, but this year we're teaching it remote because of the COVID-19 pandemic. I know most of you are at home and spread out across the country and around the world. Welcome to the class. This video is one of 4 videos that I'm going to ask you to watch before we start the first lecture Monday morning at 10:30. Altogether should total up to be about 50 or 60 minutes of video. And that will be the typical arrangement. We'll have a segment of the course that's synchronous and a segment that's asynchronous. And this is the asynchronous or look at your own time part. So I want to introduce myself. I'm Corbin Cobalt. I'm faculty in the physics department. I'm a co-chair in the department. I do research in experimental astrophysics. I study the origin of cosmic rays and gamma rays from objects coming from outer space. My co-teacher for this class is Harsh Mathur, and in principle, we're both involved in the course. So if you have questions about anything having to do with the course, you should feel free to talk to him. He mostly takes charge of the Physics 122, the electromagnetism component of the summer course, and I mostly take care of the class for mechanics. But occasionally we may take team. Let's see, what else do I want to tell you? Oh yeah, here's the thing about the summer course, and it's true whether it's being taken online or in person, and that is that the course is structured as an intensive flavor of the regular semester physics course. So if you were taking the class in the fall or the spring semester, we would have 14 weeks of instruction with 3 exams, a final exam, labs, the homework assignments, the whole thing, corresponding to a regular calculus-based college-level introductory mechanics course. And for the summer course, we're doing the same thing. And the only difference is that instead of having 14 or 15 weeks to complete the work, we're going to compress it into 5 short weeks of the month of June and then a couple days in July. And because we're covering the same material at the same level and the same workload, but compressed by almost a factor of 3, what that means is that the workload for students in the summer class will be on the order of a factor of 3 more work. So it's an intensive course. It's a course that what I tell students is if you're doing anything else besides taking this course, I wouldn't recommend you do much else besides taking this course. This course, this course will take most of your active working time over the period between now and the semester. I don't recommend that students take another course besides this one. I don't recommend the students work a job or have another activity that takes many hours a week besides this one, because the pace is going to be pretty fast. We have 4 lectures every week. We have an exam every week. We have 2 homeworks every week. We have a set of labs that you have to do, and it all goes by quite quickly. And we recognize that the intensive means that it will take more time and effort to absorb things because you won't be able to mull on it as much. But again, if the students who come to this summer are intensive tend to be well motivated, and it usually works out quite well. But the only tricky part is if you've got something else going on that might interfere with your participation in the course. So I do recommend that you, and so far as possible, clear your decks for the month of June so that you can focus on this course. So just to kind of highlight the structure of the course. So here, this is kind of a simple calendar. Kind of shows what we're going to do. So this is June, and then just a little bit of July here at the end. So we've got 1, 2, 3, 4, and then a 5th week. The class itself, so if this is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, then the class itself, we connect Mondays through Thursdays. So this week, next week, the week after, and then one's last week. This, by the way, corresponds to July 1, and this is July 2, right here. And the structure will be the same on Monday, Wednesdays, and Thursdays. So on Monday, Wednesdays, and Thursdays, what we'll do is I'll give you these videos that you can watch in your anytime you want. It's up to you to decide when to find your time in your schedule to see them. But I'll ask you to complete, and I'll expect you to complete watching the videos before 10:30 in the morning on Monday, Tuesday, and Wednesday. And those videos will all together for each day. Well, I'll try to keep it to less than an hour. Typically, I'm going to aim for 40 or 50 minutes. These videos will introduce the material of the course. So they'll basically define what I expect you to know and how I expect you to know it. But then each day at 10:30, I will start a Zoom session. I'm going to call that the active component of the course. This is the chance for the class to meet collectively. And again, this is 10:30 Eastern Daylight Time on Monday, Tuesday, Wednesdays, and also it turns out the same thing on Thursdays. And the active sessions are your chance to participate with and engage with the material in an active way, in a synchronous way instead of an asynchronous way. And the idea here is that we will, in the active sessions, we won't introduce new material. Instead, what we'll do is we'll work example problems, and we'll take some time to respond to student questions. And then most days I'll have an in-class activity that is to be done. It's not graded, it won't be required, but it's an in-class activity that students can work together on or individually on to check their understanding of the material, to go back and forth, basically a warm-up exercise in advance of the homeworks. So you should expect those to appear, those sessions to appear 4 days a week, Monday through Thursday from 10:30 to try to end the formal part of the session well before 10:30. I'll also hang around after those morning Zoom sessions so that any students who have questions about homework or any of the study material, that'll be a chance to interact with me in a live way. Now, I want to emphasize that even though I'm encouraging you to be at the live session every morning at 10:30, I'm not requiring you to do it. I'm not expecting you to do it. I know some students are on different time zones. Being at that class at that particular assigned time, which is when we're going to have it, might be challenging for all students at every session. So you're not required to be there. And like the regular sessions, those active sessions will be recorded. So you can watch what I'm doing and see the example problems and listen to me interact with the other students and get access to the in-class exercises to do on your own if you'd like. But it's entirely up to you whether you want to come in person or not. That's fine for the regular sessions, Monday, Tuesdays, and Wednesdays. Now on Thursdays, there's a different thing, and the different thing is that every Thursday at 9:30 in the morning, Cleveland time, we will have an exam. I'm going to call them the ones this week, next week, the week and after. We call these hour exams. They won't last more than an hour. They'll be on the material that you learned earlier in the week up through Monday or Tuesday, typically in the modules. The material is divided by modules, as you'll see. And the hour exams are designed to basically keep you going and check your understanding. The first hour exam, which is this Thursday, June 1, 2, 3, 4, June 4th, the first hour exam will be on the material that we've covered in the first two classes. And here's the good news. The first hour exam is entirely practice. It doesn't count for any points whatsoever. It's basically a mechanism for you and I to make sure that we understand how to do exams remotely and that we've got a scheme that works and that we're all comfortable with. The basic scheme is I'm going to run a Zoom session. I'm going to send you a PDF file by Canvas. It will have a password on it. You'll download it to your computer, laptop, or phone, write out the problems on a piece of paper, scan them in just the way you're going to do with the homeworks, turn them into PDFs, and then send them back to me within the time period of about an hour. There'll be typically 2 problems for you to work, maybe 3, depending on how the problems are set up. And it will take between 40 and 50 minutes to do each of these exams, and then with a little bit of time at the beginning and end for downloading, doing exams, and getting them back to me. So we'll do a practice run on this on Thursday and make sure everybody's happy with the technology and that it works reasonably well. And then we basically iron out the bugs. The exams on the next week, there's then 3 other hour exams, and each of these exams are worth, well, the default is 5%, 10%, and 15%. But if it turns out that it's better for you to have it be 10%, 10%, 10%, we'll grade it however it works to your favor. Right? So in other words, the first hour exam that really counts is not until next week, Thursday, and it only counts for 5% of the exam grade. And then the one after that is 10%, and then the one after that is 15%. So hopefully by that point, you're used to the exam taking and you're basically on top of the material. And then finally, a week after that, the 5th week, on Thursday, July 2nd, is the final exam for the class. And in that case, the final exam will last more than an hour. In fact, it's scheduled for 3 hours. But the plan, again, is to break that exam into 1-hour chunks and to do each part. And each of these exams will basically focus on the material from the previous week. And then the final exam will focus on the material for the whole semester. So this is kind of the battle plan for what we're going to do. By the way, if you're curious, I'm coming to you from my residence, and I've got this chalkboard basically special for the class. I've put it up on my wall. I like it. It erases reasonably well, and it's kind of old school to use a chalkboard, but that's kind of what I like, and so hopefully you'll find it legible and helpful. A couple other tactical things for the course. So the first thing is we don't have a formal textbook for the course. No required textbook. If you have a textbook, introductory textbook, any introductory textbook is fine. I have a couple of recommendations that you might like. One is the textbook by Ohanian and Market, which is a standard, chunky introductory calculus-based textbook broken into standard chapters. Those chapters will correspond pretty well to the modules that we use. But I'm not going to give you any assignment readings from that textbook. If you like using textbooks, I think it's a fine textbook. It'll work just fine. Another textbook you might consider is this one by Shanker. It's called Fundamentals of Physics. And the one reason I highlight this is because if you're going to be taking Physics 122 in July with Harsh Mathur, he likes this book and he will often recommend materials from that. But we're, again, for 121, even though this is recommended, any textbook you want to use will work. This is material that's basically hundreds of years old in terms of its fundamental foundations. So any decent textbook will be fine. In terms of what you need to know for this class, though, the definitions will be in the context of these so-called module review sheets. Each module will have a review sheet that kind of looks like this, and it's included in your handouts in the Canvas material, and it basically is a kind of condensed version of all the things you need to know. It's not a textbook. It doesn't give you all the examples and details, but it tells you, it delineates basically what you need to know, what you're going to have to cover, what we're going to be doing. And between that and these lectures and our interactions in the online sessions, that will define the material of the course. What else do I want to tell you? Oh yeah, this is important. So for the laboratory component, we're going to ask you to use these IO lab things. The good news is that this is a solution to an otherwise intractable problem. At Case Western, the introductory mechanics and electromagnetism courses both have a required component of the laboratory. It's not optional. This is a 4-credit-hour course, 3 credit hours associated with the lecture and exams, and 1 credit hour specifically to the labs. The labs are coordinated and run as a separate component of the class. You've got a separate Canvas page, you've got a separate grading. The whole thing is, but it's part of the course. There's no way to separate them. There's no way for us to give you a grade for Physics 121 unless you participate in the lab course. And the only way to participate in the lab course now is to get your hands on one of these puppies, okay? There's really no alternative that we have other than you need to get this. So that's, in some sense, the word constraint, and an annoying constraint. And the good news is, as far as we know, the vast majority of you have already managed to get your hands on one of these things, and you're all set to go. Everything you need is here, and plus the material that's going to be sent to you in Canvas. The bad news is that for at least a few of you who are either in some particular situation where you're either out of the country or there's something else that's come up, for one reason or another, you haven't been able to get hands on this, here's the message. Don't worry, it's going to be okay. If you haven't got one of these yet, what we will do is we'll do everything we can to get you one. And we have a sequence of steps of increasing complexity and difficulty, but one way or the other, we're going to get you this. If it doesn't come to you by now, if you don't have it now, well, what that means is that when the labs start, and the first IO lab, by the way, is next week, not this week, then you won't be ready to take the lab. That's not optimal. We'd rather have everybody be ready. But we understand this is, we're in the middle of a worldwide pandemic. Logistically, things are bad. So the message is just be patient. Just work with us and be persistent, and we will find a way to get one of these things into your hands eventually, no matter where you are in the whole world. And we will not, I emphasize, we will not, and you will not suffer any penalty, academic penalty for being late in getting this. Now, it will be annoying if you're late because you won't be able to do the labs with everybody else. So we'll have to find a way to sort of put the late people together and have them work together. And there's a lot of logistical problems that we have to solve, but it won't affect your final grade, except if the delay is so late that you haven't finished the labs by the time we're obligated to report grades to the registrar. Then what we'll do is we'll simply give you a grade of I corresponding to incomplete. It's not a bad thing. It's not a permanent thing. It just means we're not ready to give you a grade. And whenever you finally get your hands on this, and really, from my point of view, it doesn't matter how late, once you finally get your hands on this, then you can do the laboratory component of the course, then we can issue your final grade. So that's kind of the process for the labs. All right, what other logistical things do I want to say? That's pretty much it. Again, in terms of help, extra help for the class, I'm always willing to stay after class for the active sessions and answer questions, especially people working on the homeworks that are due the next day or the next thing. The homeworks are formative assessment, which means that we will be graded leniently and for completeness and effort. The whole point of the homework is not to show us what you know, but to do them so that you learn to know what you need to do. And that's our expectation for how it works. You can always also send email to me or Professor Mather. I will also every single day between now and the end of the semester at 4:30 Eastern time, I will turn on my Zoom session and hold it open for an hour for anybody who needs any extra help, wants to have essentially office hours at the same time. If that time doesn't work for you and you want to have office hours, just don't hesitate. Send me an email. I'm happy to sit down and work with individual students and interact with you on Zoom. That's just great. I think that's everything. And then the last thing, of course, is that we're going to use Canvas for all of the interactions. The course will be divided into modules. So typically it'll be about 2 or 3 modules. I think it's 2 modules per week. Each module will be associated with homework. The homeworks will generally be due on Mondays and Wednesdays. And so you'll see the pattern of the courses we develop, but everything you need, all the assignments, everything from the exams to the homework will be coordinated from the web page. All right, I think that's everything. So I'm going to stop now. And then the next, oh yeah, just a couple of things about the videos for today. So this is the first of 4 videos. The first video is just this introduction. There's no physics in it. The second and third videos are what I would call, they're basically somewhat polished video, edited video clips that I made when I was teaching the larger lecture course a few years ago. And I keep adding new clips. And the clips are designed to have sort of the main introductory content tightly put together and introduced to you. So the first clip is on the definitions for one-dimensional kinematics, and the second clip is on the physics of constant acceleration. And you want to definitely check out those clips. The one thing about the clips is that they tell you, don't forget, they have some date, like the first clip says, this is, don't forget to turn your homework in by August something or other. No, it's obviously not August, it's June, and the clip was written for something that was done 2 years ago. So ignore those instructions. There's no, it talks about a quiz on Blackboard. Don't worry about any of that stuff. Just listen to the physics. That's the first thing. So again, there's those two clips. And then the fourth one will be basically me working an example problem today on this clipboard so that you can see what some applications of the materials that were on that clip. And that will be all the material you need to listen to before we have the online session on Monday, June 1st at 10:30 Eastern Daylight Time in Cleveland is when I'm going to start that session. Hopefully I'll have a chance to meet you all directly at that particular point in time. So talk to you later. Bye.